an algebraic method to eliminate the parameter and identify the graph of the parametric curve. Use a grapher to support your answer. There was. What color is it? What is that song from? That's a. Oh yeah. Okay. Now, use an algebraic method to well. Before we do the eliminating the parameter, let's go to the graph here and see what we have. We've got. Let's jump over to the picture. Can somebody read it off to me since I took my picture off? I know it's x equals t. T to the third minus 2t plus 3. Okay, so I'm going to go to my graph. Did it tell me what the parameters were? Because that would be really useful. No? Well, that's nice of them. Because this might give me a decent looking picture. Oh, it did give me a decent looking picture. There it is. Okay. I was concerned that I didn't have enough t values. My t values were set from a previous question that we did yesterday, -3 to 3. But, I like to leave my x min and max on -10 to 10 unless they specify something different. T min and max, I got them -3 to 3. I mean, if you don't like that, if you want to change it to like -10 to 10, be my guest. Because they didn't specify. So, I just need enough t values to get a good looking picture on my graph. I was kind of just fortunate that -3 to 3 worked. The t-step, if you make it like 0.1, that's good. What you don't want is a big t-step because then you'll end up with kind of like dots instead of something like a solid curve. Okay, now, are we okay on the graphing part? Okay, if I go back to the question, it says use an algebraic method to eliminate the parameter. Remember, I said you have to take one of the equations and solve it for t. Is there one of those equations that's easier to solve for t than the other one? How about that first one? Because it's already solved for t. Yes. So what are you going to put in the place of t in the second equation? Oh, my goodness. And you put in an x. I think we're done. We eliminated t! That is all we had to do because they made x equal to t. They made this an easy question for me. The elimination part was simple. Okay? So if you ever get a question where x equals t or y equals t, hallelujah. That makes the whole problem like 11. 11 should be an easy question. Right? Because you're just going to replace the t's with y. So there was some other one that I saw like that, 16, but that wasn't in your list of numbers. But that was exactly like the same thing. Is there another one that you want out of the 7 through 25 odds? 25, that's a great question. I just saw that one. I was like, that's a good one. Let's look at that one. Okay, on question 25, sorry. Just like we talked about yesterday, solving those for cosine t and sine t. What would you get on question 25 if you solve for cosine t and sine t. Come down here to this and solve for the sine t and the cosine t. Oh my goodness, what did they do? Those evil people. Alright, I would never do this to you, by the way, but look at question 25. What's evil about question 25? Don't look at the parameter for t. That's not the issue. I mean, it will end up... But what did they do that kind of screwed things up? What have we always said about sine and cosine? Oh, this is hurting me, folks. Come on, what have I always said? Crockett, Kale, Meyer, what have I said about cosine and sine? Cosine is the x and sine is the y, right? Come on, that's just basic, right? Well, look what they did. They made sine t equal to x over 2. They connected sine and x. Those dirty, evil people. Okay? You're right. I would not do that to you on a test, okay? Because then we're going to use the Pythagorean identity. Now, folks, we're doing the algebraic part first here. So, you're basically going to have x over 2 quantity squared, y over 2 quantity squared. Boy, this looks an awful lot like what we did yesterday. Doesn't it? What did we multiply everything by? What did we multiply everything by, Martin? Verma? Is there a fear of talking? Do people have a fear of talking? 4. Gee whiz, I wish I could unmute their microphone when I wanted to do it, right? I cannot. I can mute them, but I cannot unmute. I can request, and then they have to unmute themselves. It's ridiculous. Zoom is not created super friendly for teachers. Yeah, yes, but I'd like to be able to say, hey, what's going on? You answer the question kind of thing. Yes, you multiply by 4. Thank you very much for those of you who chatted with me instead of just talking. Now, I do understand if your microphone gets damaged or doesn't work. Yeah. Okay, now, that's a circle, isn't it? Same thing we did yesterday. Circle centered at 0. Now, if you've got a t value between 0 and 3 pi over 2, 0, t, and 3 pi over 2, that does not sound like an entire circle to me. Does that sound like an entire circle to you? I think it sounds like more than half a circle. It sounds like 3/4 of a circle. So guess what I would be expecting in terms of a graph? I would be expecting, coming out here to 2, right? I would be expecting, oops, missed. Sorry, I missed my -2 on the left. I would be expecting something that looked like that, right? Okay, so let's go to our calculators and go to the y equals. Go back to the original x equals 2 sine t. So x equals 2 sine t. 2 sine t. And y equals 2 cosine t. And I probably need to change my t min to 0 and my t max to 3 pi over 2. I'm not going to figure out what the decimal version of 3 pi over 2 is. I'm going to let the calculator do that. So I literally typed 3 pi over 2. Now when I hit the enter button, it's going to convert it to a decimal. But don't think I've typed in that decimal. Okay? Why is it taking forever to graph? Well, I don't get that. Window. Are you guys getting a nice picture? Okay, well, maybe I need to change something here. Let me go with my T-step. Is my T-step too small? I don't know. Let me put 0.05 and see what happens. Boy, this is really taking a long time. Okay, this doesn't make sense. What's going on here? 2 sine t, 2 cosine t. 0 to... Did you guys get a circle? Alright, what did you end up putting for your window? Unless I typed something wrong here. Okay, alright. Oh, now I get it? Now, why did I get that? Oh, because it converted to that. 0 to... Oh, I know why. I'm an idiot. Correct. Unlike politicians. Alright, now. I had my calculator in degree mode, and I was trying to do things in radian. Stupid. Well, okay, so we got radian. Now if I go back here, maybe this will make more sense. 3 pi divided by 2. And I'll go back to my 0.13 that I had and graph it. Alright, now. So that's what I should have gotten in terms of the picture. Now, you and I were expecting that. But we got that. Now, why? It's because they switched the cosine and the sine. That's the reason it didn't give you what you expected. I would never do that to you, right? Because we've really tried to program you guys with cosine is the x and sine is the y. So that was a tad bit on the evil side, in my opinion. That's what I was expecting, but I did not get that. We ended up getting this. From the start, you can graph it by taking what you have up there and plugging it in. As long as you have the right mode on your calculator, which I did not have, which is why I was missing the whole graph. But then when you plug them in, you can do what we did. It happened to show us it's a circle. We were expecting the whole 0 to 3 pi over 2 like we normally think of. But the problem is we didn't end up getting that because they were stupid and they switched the cosine and sine on us. And that's why it ended up looking more like that. But once again, I would not do that to you on any kind of assessment whatsoever. Cosine should go with x and sine should go with y, so that the world may be right. Okay, are there any other questions before I move on? So I need to get through these notes, so let's move on. Page 7. You guys are familiar with the definition for slope, right? Definition of slope, like, y1 minus y2 or x1 minus x2. Okay? You've seen that before? Okay. Well, what if you do it with these 2 points? Now, I have always been a big fan of writing my coordinates in a vertical fashion because kids screw it up if you don't. Sorry, that's a little hard for you guys to see. So 6 minus 3 3 minus negative 2. Okay, good question. Does it really matter if you do 3 minus 6 over negative 2 minus 3? Will you get the same result? We should get 3 over 5. Here we get negative 3 over negative 5. Are they the same? Just understand the slope definition. As long as you're consistent, you won't screw it up. As long as you're consistent. That's the slope, right? Of this particular, of these 2 points. What do I get if I multiply the top by and the bottom by t? Isn't that the same thing? What if I take one of my equations, or one of my points? Mr. Luzak, pick one of the points, either A or B. Which one would you like? I like that one too because it's all positive numbers. Notice that I took the point that she picked and I plugged it in, along with some variables, a y and an x. Look what we have here, and look what we have here. Parametric equations. What does your y equation equal? What does your y equation equal? 3t plus 6. Yay, there's your y equation. No, all you're doing is adding the 6 to the other side. How about that x equation? 5t plus 3. Now those two actually create a line, unless you specify the parameters of t. And according to this, we have a line segment, so that must mean, from geometry class, it has a starting point and a stopping point. So how do I figure out what the t value is so that I know when it starts and when it stops? Guess what? You need to pick either x or y. It doesn't matter. So, Ms. Pachko, which would you prefer, x or y? All right. So she's picking the y. Remember, it does not matter what you pick, but she selected the y values. So she's selecting the 3 there and the 6 there. So 3 is less than or equal to y, which is less than or equal to 6. Is there anything that you could substitute for this y which might involve a t? Any thoughts out there? Mr. Plummer Collins, anything I could substitute there? You got it. How do I solve this? I'm going to solve for t. Sprint Pro, any thoughts on what I should do first? I'm trying to get t by itself. Any thoughts on what I can do? Are you passing or playing? She's passing. It's Pazuski. Subtract 6. There we go. Subtract 6, subtract 6, subtract 6. Gives me negative 3 less than or equal to 3t, which is less than or equal to 0. Thank you, Mr. Vermont, as well. Next. I got, nice. Miss Germa and Mr. Google divide by 3. Guess what? You figured it out. And if you had used the x equation, you would find the exact same result. The only difference is, if you choose the x, so since Ms. Pachka chose the y's, I went up there and I picked the 3 and the 6. Suppose I had chosen the x's. What would I have selected for the lengths or the values on either side? Negative 2 and 3, thank you very much. You went right back up there and you chose the x values that you see in the coordinates. Negative 2 for the x and 3 for the x. And then, instead of Mr. Plummer Collins telling me to do 3t plus 6, he would have told me 5t plus 3, and we would have gone through the same process, and guess what? We would have gotten the exact same parameters for t. So, as long as you stay with either the x's or the y's, you'll get the parameters for t. So, we needed these with those parameters for t. So you start out basically identifying the slope, and that's how we got the 3 over 5. And yes, then I multiplied. See, it is not letting me, for some reason, it is not letting me zoom in with 2 fingers. Let's be glitchy. Well, let me just double check, make sure I didn't accidentally. Oh. Somehow that got switched. Thank you very much. It is a little different here when you get to this point right here. Yes, you multiply the top and bottom of the slope by t. That does not change the slope. But then I set it equal to, and I have to pick a coordinate. Mr. Luzak chose 3, 6, so that's what I chose to plug in. You've got some variables, x and y, with the 6 and the 3 that she chose. Then you've got your parametric equation, one across the top and one across the bottom. You just have to solve for x and y, and then go about finding the parameter. Yes, I'm sure you'll have to practice that. It's not too bad of a process. Yes, it will be tested on. Okay, next page. Yes? I hope so. Okay, as punishment, fill this orange format. When an object is launched, whether the baseball is thrown or hit or a golf ball or something like that, it has a vertical and a horizontal component. The magnitude is represented by the original velocity. But your components on the x are based on cosine times the original velocity and sine times the original velocity. These equations are something that you need to have, that you need to know. They are the same in every single one of these objects thrown problems. You've got your x equation and your y equation. To be quite honest, your x equation is based on distance equals rate times time. The good old dirt formula. rate is v sub 0 cosine theta. The other one is something you're familiar with, at least a little bit familiar with, because that looks an awful lot like what you did in Algebra 2, the y equation. The only difference is that you didn't talk about the original velocity in terms of its vertical component only. I guess we could have assumed that the sign was 0. Yeah, because that would be a 1. These two equations we're going to need. We're only going to be dealing in feet, by the way. Only dealing in feet. You can see, I know that I'll stick to feet. We won't change to meters. So the constant negative 16 is always going to be the same in front, okay? You don't have to worry about me doing anything like that. Now that would be a little tricky. So Kevin hits a baseball at 3 feet above the ground with an initial speed of 150 feet per second and an angle of 18 degrees with the horizontal. Will the ball clear a 20-foot wall that is 400 feet away? So, ball's hit. Where is the wall? We know it's 400 feet away. We know it's 20 feet tall. But just like I talked about yesterday, is that 20-foot wall there? Is the 20-foot wall here? Is the 20-foot wall there? Is it over here? We have to figure that out. I'm going to suggest you start with your x equation, and then we'll move to the y equation. So we know that 150 was the original speed. The angle was 18 degrees. And we know the overall horizontal distance from start to finish for the wall is 400 feet. Now, how long will it take to reach 400 feet? We really need to solve this for the time. How many seconds is it going to take to reach 400 feet? And I'm probably going to need to have my calculator in degree mode, so I would make sure I switch it over to degree for this particular question. So let me write that down. Degree mode. Yes, I will see what you said in the chat. Do you have to draw a triangle? No, not necessarily. So what am I going to divide 400 by? What am I going to divide 400 by? So that I can get t. Isn't it this thing right here? Okay. So we're going to divide by, and I'm just going to use parentheses. Yes, I know I'm getting a little lazy there, but that's okay. Let the calculator do the work. It is the Scott. So I got about 2.804 seconds. Were you able to get that? Anybody not able to get that? 2.804 seconds. Now would be a good time to yell at me and let me know the division. Thank you very much. What I want to know is how high off the ground that thing will be at 2.804 seconds. You'll notice that I wrote out the other equation. I got the speed, the original speed at 150 feet per second. Please make sure that you do sine in the y equation and not cosine. That will mess everything up. Cosine goes with the x equation, sine goes with the y equation. I've replaced every one of the T's with 2.804 seconds. And of course, when we hit this ball, it says that it was hit 3 feet off the ground. That's why I have that number at the end. So use your calculator to find out how high off the ground it is. At 2.804 seconds, I want to know how high off the ground this thing is. Compare with your neighbors to see what they got. Around the room and check the people here. You guys at home in the chat, adding this, but you forgot to multiply by that. Okay, well, because you said that plus that, it will line this number and that number, so that will be an issue. That's not what I got. For me, that use that one. You forgot a negative. Yeah, if you forget the negative, that's going to cause a big issue. I got 7.17. The motion is passed. Now, if this thing is 7.17 feet off the ground, I think we're sitting in this situation right here. It's a 20-foot tall wall. It does not make it. Right, so it hits the wall, and now, if the guy doesn't catch it, obviously, you probably get double out of it. At least, unless you're really fast, maybe triple, depending on the gap. Now, 7.17 feet could be a home run in some ballparks because they have maybe a certain section with a really low wall, but not always. In this case, we got a 20-footer, so not happening. Any questions about that? So if you kind of follow my logic there, I used the x equation first to find the time. Then I plugged it into the y equation to figure out how far off the ground it was. There's coming a question that we'll be talking about a golf ball, and we're actually going to reverse those because we want to know when it hits the ground, and then we're going to measure how far the golf ball went. So we'll actually solve for the other equation for y, and last night I learned a really cool way to do, let me show you right now so that if you come across a problem like this in homework, you can use this. I'm glad I didn't know it. I'm glad you guys probably don't know about it, but you might know about it. I mean, you guys are smart kids. Okay? No, not Photomath. Seriously. Okay. Under the apps feature, I learned about an app yesterday that was kind of helpful to me. And it is, in my calculator, the 8th one down. Now, I don't know if the old style calculators have this, or if it's just the new style calculators. Because I don't know if there's, let's see, apps. And let me see if it's... Should be. It's a polynomial simulation 2. So that's what mine says. POYSMLT. Okay. Why do you not have it? I don't know. I just saw this last night. Somebody else said it was 9, and I was like, well, not on mine. It's 8. Anyway, if you choose that one, the very first one is the one we're looking for. Polynomial root finder. Okay? Polynomial root finder. Now, you get to choose what the power of the polynomial is. And I want a second degree polynomial. Okay? You can leave everything here real, normal, make sure you're dealing in degree if you're using any kind of sine or cosine function. And then you can use the next feature. I press this, the graph button will identify this next feature. Well, look, you can actually plug in A, B, and C and let the calculator do the quadratic formula. What? Are you kidding me? I just found this out last night. It's so cool. This will come in real handy for the golf ball question because we're going to be, now obviously that'll stay negative 16 for us because I promised we would stay in feet. But, maybe we might have a golf ball hit at 150 feet per second with an angle of, maybe we hit it at a 25 degree angle. Okay? So that ends up being my coefficient of the linear term. And then I hit the golf ball off the ground, so I'm going to leave it at 0, And then come up here to where it says solve and just let the calculator. So it would take my golf ball 3.96 seconds to hit the ground if I hit it at 150 feet per second at an angle of 25 degrees. That's going to be helpful to you when we get there, okay, when you run across a question like that. Yeah. He's just like, I got a place for my calculator right here in my golf bag. Let's check this out, guys. While you're hitting, I'm going to measure the angle and the speed, and let me do a prediction on how long it's going to get there. Right, yeah. And then you can plug it into the x equation to find out how far the ball went, right? So you could say, I think it's about right there. Assuming it doesn't bounce and roll. Assuming that it can come, right. Like really wet grass that it just sticks in the ground. Yes. Okay, so you have some more problems that I put on the Google Sheet for you to work on tonight. Not very many questions, quite honestly. And then we will be reviewing 6.1 and 6.3 tomorrow. And then you will be showing me what you know from 6.1 and 6.3 about vectors and about parametric equations on Thursday. So we'll have a test on that day, and then we'll be done with that and move on after spring break